Hi everyone, this is a video of the answers for that extra review for the midterm that I made. So this looks really similar to the test, so make sure that you understand everything on it. If there's something that you don't understand, then try it again. Use your notes. But you should have done this in class today. So number one, if I have a regular octagon that I'm rotating, an octagon has 8 sides. Right, so all I'm going to do is I'm going to take 360 and I'm going to divide it by 8. Now that's 45. That's the minimum number of degrees to rotate it to map it back onto itself. And any multiple of 45 is also an answer. So remember, sometimes they ask you for the minimum. If they ask you for the minimum, the answer is 45. Sometimes they just ask you for an angle of rotation, and any of these answers are fine right here. And sometimes they ask you which is not an angle of rotation. And that would be choice A, because 40 degrees is not one of those angles up there, but 90, 225, and 270 is. You also might have a question where I give you a picture of some triangles and I tell you something about it. So this is like doing a proof without actually writing the steps of the proof. AC and BD bisect each other. That means they cut each other in half. So all I did is I went to AC and I cut it in half. I went to BD and I cut it in half. The two things that you're allowed to add to the picture, if they're vertical angles, which I have in this picture, I marked that, or if they share a side. So these triangles are congruent by side angle side. Number 3, the triangles are congruent. Remember, the order of the letters tells you what's congruent to what. So choice 1, that is a correct statement. You're supposed to write whether each statement is true or false. I wrote yes or no, but it should have been true or false. So AC is congruent to ZX. That's actually okay because ZX is the same exact thing as XZ. But AC is the first and the third letter, and ZX is the third and the first. All right. Choice 2, BC is congruent to XC. That's no. BC is the second and the third letter, and XZ is the first and the third. So that's why that's a no. It definitely gets a little bit more complicated when I have the angles with the 3 letters, but just make sure that the order of the letters is exactly the same. I highlighted it so you can see what's going on, but angle CAB is the third letter, the first letter, and the second letter, but angle ZYX is the third, the second, and the first. So the order of the letters tells you what matches up. In choice 4, B is the second letter, C is the third letter, A is the first letter, and Y is the second letter, Z is the third letter, and X is the first letter. So that would be a true statement. Choice 4, if you're asked to write the equation of a line that's perpendicular, so anytime I want to write the equation of the line, you're thinking of your point slope formula, y minus y1 equals m parentheses x minus x1. I need 2 things. I need a point and I need a slope. They gave me the point. The point is 5, -1, and they told me information about the slope. It's perpendicular to this line right here. So that line has a slope of -3, so perpendicular would be a negative reciprocal would be 1/3. So you're using the slope of 1/3 and the point 5, -2. That's your x1 and your y1, and you're just plugging that in. So it's y minus -2, which is y plus 2, equals the slope, that's your m, 1/3, and then parentheses x minus x1, so it's x minus 5. Definitely have a problem where you have to use the Pythagorean theorem, like number 5. So a square window, remember square has 4 sides that are congruent, and all the angles are right angles. So I have a square window, the sides are 16, all right, and I'm trying to find the length of the diagonal of the window. So I just highlighted that for you. You can see I have a right triangle. 16 squared plus 16 squared is x squared. 16 squared is 256. 256 plus 256 is 512. And then I take the square root of 512, which is 16 radical 2 when you simplify it. Remember, if it's multiple choice, though, you could always just take square root of 512 and turn it into a decimal, and then turn each of the answer choices into a decimal. Now, 16 is a distance formula. You can see its distance because they're asking you to find the length of P prime. They do give you point P. The problem is they don't give you point P prime, P double prime. You have to figure it out, and you figure it out after doing whatever that transformation is. So first you're going to take point P and you're going to rotate it 90 degrees. Remember, if it says rotation, it's always counterclockwise unless it says otherwise. So rotation at 90 degrees, you change the sign of the y, and the y goes in the x position, and the x goes in the y position. So that becomes p prime, which is 5, negative 2. And then you're going to reflect that in the y-axis. When I reflect in the y-axis, it changes the x. So basically, these are my 2 points highlighted in yellow, and I'm just using my distance formula on that. So distance formula, I'll write it down for you. I used it here, but here's the formula. x2 minus x1 squared plus y2 minus y1 squared. And I did that. Negative 5 minus 2 squared plus 2 minus negative 5 squared. Remember, if you have a negative, you're squaring it. So negative 5 minus 2 is negative 7, but I'm squaring it. So you just get 49 plus 49 is radical 98, and that simplifies to radical 49 times radical 2, which is 7 radical 2. We've talked about this in the last unit that we just did. The ways to prove a quadrilateral is a parallelogram. There are 4 different ways. So you wouldn't have to draw this, but you might have a multiple choice question dealing with this concept. So the first way is both opposite sides are congruent. That's the picture on the left. Or you can have both opposite sides parallel. Or you can have one set of sides congruent and parallel. Or the diagonals bisect each other. Okay, the way that's not a way to prove something's a parallelogram is if you have one set of sides congruent and a different set of sides parallel. So that's not a parallelogram. The others are all ways to prove that. Partitioning formula. Here's my partitioning formula. I'm highlighting it in green right here. x1 plus a over b, x2 minus x1, comma, y1 plus a over b, y2 minus y1. So I have a directed line segment. I'm giving you points A and points B, and I'm going to, point M divides it such that the ratio from AM to MB is 1 to 3. If it's a ratio of 1 to 3, there are 4 parts total, so that fraction is 1/4. So it's just going to be negative 1 plus 1/4, parentheses 7 minus negative 1. Now that whole thing can go into the calculator, and that gives you your x-coordinate. And then 5 plus 1/4, parentheses 9 minus 5. And that can all go into your calculator and gives you your y-coordinate of 6. How can I prove that a parallelogram is a rhombus? The most common way is with the diagonals. So just remember, in a rhombus, those diagonals are perpendicular. You could also show that all the sides are congruent, or if you already know it's a parallelogram, you would just have to show that 2 adjacent sides are congruent to each other. How can I prove that a parallelogram is a rectangle? Again, most common thing is the diagonals are congruent to each other. That's the typical question that they ask on the Regents. But you could also show that it has a right angle. And how would I show a parallelogram as a square? If you show those diagonals are congruent and perpendicular. Or, of course, you could just show that it has a right angle and 2 adjacent sides that are congruent. Perpendicular bisector, there's 2 things going on with that word. Bisector, which means it cuts it in half, and perpendicular, and that's talking about the slopes. So the first part of this question, they want to know what's the coordinates of point M, which is the midpoint, because basically it passes through point M, which lies on AB, and the perpendicular bisector goes through the midpoint. So I find the midpoint. I add the x's, negative 3 plus 7 divided by 2, and I add the y's, 7 plus negative 5 divided by 2, and the midpoint is 2, 1. Write an equation of the slope of the perpendicular bisector. Write the equation of the perpendicular bisector. So the next part is to find the slope. The slope, remember, is just your change in y over the change in x, meaning you're going to subtract the x's, subtract the y's, subtract the y's, that goes on top, negative 5 minus 7, and subtract the x's, 7 minus negative 3, that goes on the bottom. Now once you know your slope, remember it's perpendicular, so you got to take that slope and flip it and change the sign. And once you do that, you're going to take that perpendicular slope and you're going to take that midpoint, and all you're doing is plugging it into the equation of a line. Y minus y1 equals m, parentheses, x minus x1. Now, I just did this construction by hand because I can't use my compass on the iPad, but you put your compass, if I want to bisect an angle, I put my compass on point B. I open it up as much as I want, it really doesn't matter, and I draw this first arc that I have right there. Now that arc touches the top of my angle and the bottom of my angle. So where I have those two, you know what, let me make them red. Where I have these 2 points of intersection from that first arc, that's where I put my compass next, and I have arcs 2 and 3 out in the middle right here. And then where that is, that gets connected with point B. That's how I bisect the angle. So bisect the angle, remember, means to cut that angle in half. And then a proof. This is really just a basic proof. I want to prove that JL is congruent to NL. In order to do that, I have to prove that my triangles are first congruent. So look at your given. Your given is step 1. You can see in the given I have some perpendicular lines. Perpendicular lines form right angles, so that's step 2 and step 3. So step 2, first I say they're right angles. Angle K and angle M are right angles. Definition of perpendicular lines. Then I say they're congruent. Angle K is congruent to angle M because all right angles are congruent. Also, I have L as the midpoint. A midpoint divides a segment into 2 congruent segments. So I go to L, it's the midpoint of KM, so I cut KM in half. KL is congruent to ML, that's step 4, definition midpoint. You can see that I have vertical angles here. I call those angles angle 1 and angle 2. I say they're congruent, and the reason is vertical angles are congruent. Make sure you're marking your diagram because then you'll know when you're done. I can see now that the triangles are congruent by angle, side, angle. Excuse me. And then once my triangles are congruent, all the corresponding angles and sides are congruent. So JL is congruent to NL by CPCTC. All right. So make sure that you're comfortable with any of these formulas. You will have to memorize them. I'm not going to give you any formulas. And you should do fine. Good luck.